Okay, connective tissues function in supporting our body, so our bones, our type of connective tissue, tendons, type of connective tissue, protection, our bones protect our organs, production, for example, the bone marrow in bones produces red blood cells and white blood cells and platelets. And for storage in our bones are yellow marrow in our bones store lipids. And also for production, our blood cells produce, bone marrow produces white blood cells which function in protecting us from disease. So functions, support, protection, production, and storage. Structure of connective tissue. Connective tissue has two important parts. We have these living cells, and the living cells are a bone cell or blood cell, chondrocyte, and then the non-living matrix. The non-living matrix is the material that surrounds the living cell. And the non-living matrix can be solid to semi-solid to even fluid. And the non-living matrix also has fibers in it. Major connective tissue types, or cell types. Fibroblasts. Fibroblasts are cells that produce fibers for that non-living matrix. Macrophages are phagocytic cells, so they go around and eat, say, bacterial cells that want to do us harm. Mast cells produce heparin and histamine. Heparin makes blood vessels leaky, and histamine, heparin prevents clotting, and histamine makes them leaky. Right. Connective tissue fibers. All the connective tissue we're going to talk about these different fibers in there, but collagenous fibers are thick fibers. They're made of collagen, and they have great tensile strength, which means if you stretch them, they're not going to break. We have a lot of collagenous fibers in places where we need strong tissue, and that's in like dense connective tissue, which is what tendons and ligaments are made of. So it helps to hold our muscles to our bones and our bones to our bones. Elastic fibers aren't quite as thick, but they have a lot of a protein called elastin. They're highly branched, and they're places where we need to have a little more flexibility. So vocal cords, air passages, where we can allow them to stretch. Reticular fibers are like collagen, but they are very thin, highly branched, and they help to support some of our organs and divide up some of our organs. These are the different types of connective tissue that we're going to talk about. So we're going to talk about loose connective tissue, adipose, reticular, dense, and elastic. And we're going to talk about a bunch of different cartilages, bone and blood, for specialized connective tissue. All right. Areolar, loose connective tissue. It's going to have a lot of fibroblasts in it, which these cells right here are all those fibroblasts. They're going to make fibers. Fluid to gel-like matrix. Elastic fibers, so they allow lots of movement. And we have this areolar, or loose connective tissue under our skin, allows our skin to move over the underlying structures, and also separates out parts of our muscles. Adipose tissue, the cells are called adipocytes, and adipose tissue is our fat cells, our fat tissue. So stores fats, we have it in our skin and around some of our organs. Notice with the adipocytes that you don't see a lot of organelles in here. It's really just a storage cell. You can see the nuclei are kind of pushed off to the side so you can store as much fat as possible. Reticular connective tissue, lots of reticular fibers, and you can see some of those very thin collagenous fibers in there. Reticular connective tissue helps to divide up the different parts of the liver, spleen, and our lymph nodes. Dense connective tissue. Dense connective tissue is going to have lots of collagen. It's called dense connective tissue because notice you don't see much space in here. So all those collagen fibers are packed really tightly together. Not a lot of space in there. Tendons, ligaments, but because there's not a lot of space, there's not a lot of room for blood supply. So that's why tendons and ligaments take a very long time to heal, because there's not a lot of room in there to get blood in. Elastic connective tissue. There's mostly elastic fibers, but there's still some collagen fibers in here. And these collagen fibers are there to give strength to the tissue, but there's a lot of elastic fibers to allow the tissue to stretch. Okay, so we have these in our heart, as you can see here, to allow there to be some strength, but also the heart has to be able to expand and come back to its original shape. Places like the aorta would have this elastic tissue. Okay. Bone is a special type of connective tissue. And bone has a solid matrix. And that solid matrix is made of calcium salts, or really mineral salts. Bone supports and protects our body. It helps to, or it forms our skeleton and protects our vital organs from damage. There's also our bone marrow is found within the bone. It gives us a place for our muscles to attach to so we can move. And then bone cells are called osteocytes. Okay? And the osteocytes live in, say, like this little lacuna here, this little indent in the bone tissue. We'll see more of that when we get to that unit. Okay, cartilage. Cartilage has generally a rigid matrix. The living cells in cartilage are called chondrocytes. Cells that make cartilage are called chondroblasts. And there's three types we're going to look at. There's hyaline, elastic, and fibrocartilage. Hyaline cartilage has this glassy appearance. And the hyaline cartilage, a glassy appearance under the microscope. And we find hyaline cartilage in the ends of our long bones, so in the joints, in your knee joint, those ends of those bones will have hyaline cartilage in it. Our nose, our respiratory passages, and then the embryonic skeleton, so the skeleton of embryos, are made up almost entirely of hyaline cartilage, and later that turns into bone, or is replaced by bone. It doesn't turn into bone. Elastic cartilage is more elastic. We have the elastic cartilage in our ears, for example. So your ear can be bent over and go back to its original shape. And you see you still have the chondrocytes in here, but then lots of elastic fibers in that elastic cartilage. Fibrocartilage is a tough cartilage. So you would expect if it's tough and going to be a little more strong, you're going to do lots of these collagen fibers in here. So you see these collagen fibers running through this fibrocartilage. Fibrocartilage is used as a shock absorber. So we find that in our intervertebral discs, so the disc between our vertebrae, and then places like the pads in your knees have lots of fibrocartilage in them. Okay. Blood is also a connective tissue. Blood has a liquid matrix called plasma. So plasma is that non-living matrix for our blood cells. We've got red blood cells, which just function, don't just, but function to carry gases in our blood. White blood cells function in our immune system, and platelets function to clot our blood. Blood transports things throughout our body, and those white blood cells, we said, defend against pathogens. All right, so which one is this? This is adipose tissue. Notice the nuclei are all pushed off to the side. Those cells look pretty bland. Okay, this one, notice there's lots of collagen fibers in here, and some fibroblasts. So this is dense connective tissue. This one's hyaline cartilage. This one, you got some collagen, but lots of these elastic fibers. So this would be elastic cartilage. And this one is that this one is fibrocartilage. Yeah, so you still have that. Bone and blood, where the red blood cells are kind of mauve in color, and then the purple ones, or the ones with purple nuclei, are white blood cells.